Here's a slightly more complicated K-map. We have a 3-input Boolean expression that we're going to represent. I have the truth table here with our given outputs, and this is our actual expression. So it's true for 0, 2, 3, 4, and 7. And so I've already filled this out to simplify it. And what I've done here is I've already drawn a 2 by 1 K-map, or a 1 by 2. I don't really care if you do columns first or rows first. In fact, it doesn't really matter. I'll show you that in a little while. But what does matter is that you're consistent. So what, again, I really encourage you to do is to number each of your cells in your K-map here. So I started with, this is A on top. So when A is 0, B is 0, C is 0, that is my 0th row, and that's where I put a 0. And I have these little subscripts. There's 1, and notice here this is 3, 1, 1 before 1, 0. So you go 0, 1, 3, 2. That's important. It works with the K-map, so don't stress over it. Just remember that when you're counting up, you go 0, 1, 3, 2. And again, in this other column, we have when when A is equal to 1, so that's starting from this half of the truth table. We have 4, that's 4, so that's 1, 0, 0. Then we have 5, that's 1, 0, 1, 5. And then I'm going to skip this one, go to the last one. We have 6, that's 1, 1, 0, so we got 1, 1, 0. And the last one is 1, 1, 1, 1, 1, 1, 7. And what I've also already done is I've marked the areas where the variables are true. So in this column, A is equal to 1. So I've marked that as the A column. Here, in both of these rows, B is equal to 1. C changes in these two rows. So the only thing that's constant is that B is equal to 1. That's the only true constant here. And then in these two middle rows, I've got C marked out because here you can see that B changes, but C stays constant. Now we can go ahead and fill out our K-map with our outputs. So we have our 0, and you could do this either with the truth table or you could just do it with the expression up here. So for 0, a 2, a 3, a 4, and a 7. The other elements become zeros. And now we match our truth table completely. So this is a case actually where we're going to use multiple colors. There's different ways you can group your ones in this map. Of course, anytime two ones are touching, either vertically or horizontally, you can group those two ones, and that will become a minterm in your expression. Now, there is a little bit of a tricky one here, because you could, if you really chose to, mark this going off the edges, wrap around, and get this one on the top. We're not going to use that one in this particular case, but we will in a future case. But just note that that's possible. But what we want to do is get the largest numbers of ones grouped together. Now you can overlap, but it really doesn't do anything to overlap unless it's going to include a 1 that is not in any other group. So for example, if we grouped this one and this one, you wouldn't want to group this one by itself because it's connected here or it's connected here. And again, you can only group things in powers of 2. So we have 2 here that could be grouped, or 2 here that could be grouped, not these 3 wrap around to the top here. Just a pair. So what you want to do is only overlap when you have to, basically, to make a larger group of ones. And again, this is where the colors are going to come in. So I'm going to try this. I don't have a whole lot of different colors of markers here, but I've got, that's not looking too promising, a green, a blue, a dark blue, and then a light blue. So we'll see how this works. So I'm going to group first these two 1 values. So those two are being grouped together. And this is light blue. And as I mentioned before, we're going to just create with the light blue a little box down here, and this will be our legend. So the thing that's in blue we'll come back and write an expression for. I'm going to use dark blue to represent, maybe I'll use orange. That'll be a little bit different here. I'll use orange to represent this pair of ones. So that may be a little tough to see as well. I'll just kind of color it a little more. So this is bright orange. And I'll have an expression for that. And then finally, what I'm going to do, since I have this 1 all by itself, I'm going to connect it right here. That's the easiest thing for me to see as a group. Now it could be connected all the way wrapped around, but usually that's a little bit more complicated to look at visually. So I'm going to just make a green grouping here. And so this will be my green expression. So now I go through with an eye looking at which columns and which rows are true in each of these cases. So for this blue one, just these two, we can look and see that A does not stay the same. A changes, so A is not going to be included in our midterm here. We have an easy to see thing here is that it's not part of the C column here. The C columns are in the middle, and anything that is not in the C column is C naught. So we have a C naught, and we also have a B naught, because you can see that here's the B columns. It's not part of those columns either. So it's B naught, which brings us to these columns, these two, because B naught means B is 0. In each of these cases, B is 0. And then it's also C naught, because C naught says C is 0. So C is 0 here. So for this one, we'll have B naught, C naught. For our next one, we'll look at the orange. And here, we can actually see that this is the exact opposite of the last one. We have, it's part of the B columns. So out of these two, it is one of these that is also in the C column. So it's B and C. So that was pretty painless. And now let's look at a vertical grouping. So we've got this group here, which, if we look, it's definitely part of both B columns. So B is involved in this. But if we look here, C and C naught, so those cancel each other out. So it's not involved with the C's at all. And so the only thing left is to look at the A's. Here we have it in the A naught column. So this one would be A naught B. Now you might ask, why do we do it this way as opposed to maybe long ways? We could do that as well. It honestly doesn't matter which direction you fill out your table. So let's do the exact same expression, but do it in a different format. So I have made this a little too small, I believe, but we will try to power through it. So I'm going to make this A, B, and on this side I'll make this C. Again, you can split these up in any way that you want. It doesn't really matter as long as you're consistent. So, and by consistent, I mean consistent with your numbering values. So when we're drawing this up, again, remember you go 0, 0, 0, 1, 1, 1, 1, 0. So now we look and we can number each of these elements based on the A, B, and C. So this is A is 0, B is 0, C is 0. That's element 0. This is element 1 because it's 0, 0, 1. This is element 2 because it's 0, 1, 0. This is 3 because it's 0, 1, 1. I'm going to skip this, go to this one. We have 1, 0, 0, 4. 1, 0, 1, 5. Now we go to this column. We've got 1, 1, 0, which is 6. And finally 1, 1, 1, which is 7. And if you would remember, our function was 0, 2, 3, 4, 7. So now we can fill this out. We have a 1 here in our second column. In our third column, we have a 3, or third element rather. Here we have an element that's filled in 4 and then 7. The empty elements become zeros. So now let's go ahead and group this one. If we try to stay with the same colors for the same groupings, that's going to be tricky because if you notice here, we've got A, B, C. Here we have A and then B, C. So to represent the same thing is going to be a little bit complicated, but I kind of already know what it's going to come out to be, and so we'll go ahead and group it that way. So let's take the blue color, the light blue. Actually, let me make that a dark blue now that I've got the orange. So I've got a dark blue. Blue is blue. So, and we'll represent one of the values here, one of the groupings. Now there's a couple that are pretty obvious, but what I would want to do here is I'm going to try to include this guy because I don't want to end up with this one all by himself. So I'm going to actually wrap this around and group it with this beginning one here. And then of course a little box down here for our legend. And then let's see what my other colors were. Orange. I'm going to use orange. And I'm going to group these two with orange. And then finally, I have an option here of either grouping this one with this one or this one with this one. The way I'm going to choose to do this is, let's see, I'll do this vertically. So now I've grouped all of the ones without any redundancy. I don't have this one in more than one group unless, and this is the only one that's in more than one group, and the only reason is because that groups with a larger number of ones to include these guys. So oh, something that I didn't do. I neglected to put my brackets here. So let's put the C bracket here to show that this row is when C is true. And then what we could do is put, so A is true in both of these. So I will put my brackets for A, and then B is true for both of these. So now it should be much easier to figure out what's what. I want to fill that in a little bit. Okay, so now we can start figuring out the expressions for each of these. The expression for this blue one here, we look and neither of these are in the B column. They're both in the B not columns because B is the same value for both of them, and it's equal to 0. It's also only in the C not column because C here is equal to 0, and it's consistent with both of these numbers. So this one would be B not and C not. Don't confuse that A with the expression there. Okay, the next one would be the orange one. This pair, we look and it's pretty obvious that we are in the B columns pretty solidly right here. And we're also in the C column, or sorry, the C row. A doesn't play much of a role because if you notice, A changes from 0 to 1. So that cancels itself out. So we're just in B and C. And then finally, this last one, the green one here, we have all in the B column. So B columns are here. And out of the two B columns, it's sharing the A naught column. Because this is A naught. So we have B, A naught, or A naught, B. So we can look and see if this is consistent with the last orientation that we did. So we've got a B naught, C naught, a B, C, and an A naught, B. Flip this back over. And we just look at the expressions that we came up with. We came up with a B naught, C naught, a B, C, and an A naught, B. And so that proves that the dimension doesn't matter. And I also, whenever I changed the dimension, I changed which variables were in which areas. So here, the lone variable is C, while A and B are grouped together. And in the first one, we had A being the lone variable, while B and C are grouped together. In fact, it doesn't really matter. You could have A and C and B over here. The only thing you need to keep track of is, what is this element number? What row is that representing at that point? As long as you have that, you should have the same exact Boolean expression as your output.